This video is going to be about sketching many stuff, mainly the graphs and some points. That's the main thing, but in this video I'm going to also show you some of the tricks that it's really convenient to use to do this one. So for the first thing, and we don't want to name the functions with a difficult name. Sometimes you just want to keep using the same name, f and g, but if you used it already in an earlier stage, and at this stage you want to just clear up and redefine it, whenever it's causing a problem, you want it to clear that name. You can add by separated by comma here more things to clear up. So we're going to clear f, and after that it's going to turn to blue. Then this way I already explained in an earlier video that this function actually has a main variable x, and it has some c parameter. And again, the advantage of separating c and x like this is that you can use fc as a name. The entire thing is a name of a function with a variable x. So anyway, this is a function with a cubic polynomial where c is an unknown constant here involved as a coefficient of x, and some constant term through this sign value. And whatever that you have to deal with lots of other numbers for the bounds of the graphs or indexes, and we have to define those, and you can do that in this way all at the same time. In one line you're defining CA to be 0, CB to be 3, and N is going to be 10. So we're actually about to sketch 10 different graphs, changing the C value from 0 to 3, and you will use all this initial value and number of things to sketch. And those numbers has to be, if it is defined like this, it's convenient to use later. And if you have to change this one to different number, all you have to change is just one line. You don't have to go through every line where you use this 0 and 3 and 10, and anytime when you make changes, that's going to be really handy if you define it this way. We will be using the plot command to plot all these functions while we're changing this constant a little bit, and we're going to create a table of different functions. X is, there's no x in here, x is a variable, and we're only changing c starting from CA to CB, and this is difference between CA and CB divided into 10 pieces. So that's an increment. We're going from CA to CB by increasing this amount. So after we go n times, we will arrive in there in CA, and that's the formula. So that nn here is a 10, so you will have 10 steps from CA to CB uniformly divided. So there's going to be 10 different functions. So this is a table of list of 10 different functions. It's defined as a list f. And if you put all those things, this is a one list of functions where x as an indeterminate in there. And if you plot the list, and it's going to plot all those 10 functions, which is a sketch here as we vary c, and the way the function varies is this type of a shape. Here I'm showing extra example to, if you don't want to create a complicated list, it's just a couple of or 3 functions. If you don't want to do this manually, make sure when you list the function in here, if it is not just the one function, you have to list it like this, and it begins and ends with these braces. So that whole thing is a list of function. And if you run it, it's going to show you these 2 functions like this. The following is a bit more advanced way of plotting many things. So I define a function like this, fx, so it looks like a typical function. And in this line, I'm differentiating this one k times. So if k is 1, it's going to be first derivative, and k is 2, it's going to be second derivative. This whole thing is a name of a function, and then you can define it as like this. So this is a bit advanced usage. And I want you to look at this as a function with a k variable. This whole thing is actually a name of a function, including this k index part. So it's the name of a kth derivative. The main variable x here is not showing, because what we're dealing with here is the object is a function, but we're only dealing with the names of the function. So once it's defined, if you attach the bracket x, and this is going to be really a function. The whole thing is now just a name of a function. So what we're doing in the next line, and we are actually creating a list of not a function but the pictures itself. So inside there, f higher k, this whole thing is just a name, and the variable part is now appearing. Z could be x. So this is a kth derivative of the original function here with the variable z. So it's going to sketch this one. The plot will sketch this one, but we're sketching it varying k from 1 to 4. So it's going to sketch the first 4 derivatives. And each of them here is a picture that was stored as entries of a list. So the whole thing here is not a function, but it's actually a table of pictures that was stored in this command and higher, in this name higher derivatives. To command to sketch all the pictures together is a show command. So higher derivative is a list of pictures like this, and if you use show command, it's going to show everything all together. And if it happened that it is showing too much, you only want to see y value from -5 to +5, and that controls y value, plot range. Then it'll show pictures, and these are all 4 different derivatives of plot all together. Now this will be an example of plotting points. It's kind of useful and very nice. It's going to create a very nice presentation whenever you have to kind of pinpoint something in the graph. And again, rather than typing these points and again, if you define it like this, and if you refer to P1 and P2 whenever you have to fix this one later, all you have to fix is just a one line, and this is something you need to learn if you want to program something better. So in mathematics, a way to turn this one into an actual point dot in the XY plane is the list plot command. Remember, this is going to be a list of points, so it should start with the beginning of a table again, list again, so it's a parenthesis and close parenthesis, and you list actual point. This is 1, 2, 3, 4 in XY plane. So this will be a list of those 2 points. It can be 100 points. And this is kind of the size of the points. This is how you control it. The option is a plot style, and point size 0.02, this is optimal size. You can change that to a different size. So if you do that, it's going to sketch 2 points, which is shown here. 1 point is sketched in there, and another point sketched in there. Right, this is an example. We're going to sketch a lot of points. For example, I'm sketching sine k and sine k squared. One dot means turning this one a numerical value. As we vary k from 1 to 30, if there's no increment, it means increase by 1. And then it's going to create these 30 points of x with xy coordinate in there. So that's a list of all points. This whole thing itself has a curly brace in it, so you don't have to put additional braces around this point list. This itself is a list. So if you list plot these 30 points with the same size of the points, and it's going to sketch all those points. But since there's no semicolon, it's going to show the list of 30 points. It looks just like this. I truncated so it's not really the 30 points, but it's showing that this is x component and y component. That's a 1 point, but this entire list starts from this beginning of a list symbol. So there is table list parentheses already. So the second part will be actually sketching this. And if you sketch it, it's going to show this random looking kind of dots around it. So that's the 30 points actually. So let me show you one last example. For example, I went back to this example that I showed earlier and actually added this part function. So this whole thing is supposed to be the picture. That picture is stored in here. So if I change to semicolon and enter, and it ran it, and it stored that picture in this part functions. In the next part, and I'm actually sketching these 2 points, 1, 2 and 0, 3, and I'm not showing it, and also running it, and then stored it in here. And you can actually do this in one cell. Now if you want to show these functions and the points you just generated all together, use a show command like this, and then it's going to show the functions and the points all together. So as you can see that we see those 2 points and all the functions together. The order what you put in here kind of matters. So this first one will dominate the size. If the points happen to be outside, it's not going to show. That is, the size of this picture is determined by the very first picture you put it in there. So let me show you one more trick I usually do. So it's regarding of what the picture, the show command. The first entry here dominates the kind of area that it wants to show. So if you want to kind of only see it as a certain part, and the following is what I usually do. I call this one empty box. It's a contour plot of x and y that satisfy this equation 0 equals 1, and this is a false statement, so the no xy satisfy this equation. So what it's going to generate is that just a plane where x varies from -1 to 1 and y varies from 0.5 to 4. So in this graph, it's just about the size in here. So if I put that empty box in here, and empty box will dominate the area you want to view, and everything else right here only gonna be shown, only this portion of the graph will be shown. So let's execute this one first. The semicolon, we don't want to show this empty box at this stage, and go here and insert empty box here like this. And then if you run it, you can see it only shows that smaller region. So let me make it smaller. So kind of effectively zooming in by controlling. So this is a neat trick, and if you have several things and you want to sketch it and you want to have a control on that, which part you want to show, this contour plot does a nice trick. That's it.